The last problems on homework 4 are going to deal with simplifying complex fractions. Complex fractions really aren't that complex. First of all, if you remember how to do a problem like 2/3 divided by 5/7, and you may think you don't, but to divide fractions, you multiply by the reciprocal, meaning that you always leave the first fraction alone, you just copy it down, you change the division to a multiply or a dot, and then you change the second fraction to its reciprocal, which means you flip it. So I say copy dot flip. That's the way that I remember division. So here, once I do that, then I just multiply straight across the top and then straight across the bottom. So I get 14/15. This is the exact same as if I would have had 2/3 divided by 5/7. These are the same exact problem. This right here is the same. The only difference is it's defined to be a complex fraction because the numerator, denominator, or both, in this case both, contain one or more fractions. Okay, all a rational expression is, it's a fancy word for fraction. So it's a complex fraction is a fraction whose numerator, denominator, or both contain one or more fractions. So there are two methods that you can use. The first is the one I just showed you. The first method is to copy dot flip, or to multiply by the reciprocal. But if there's addition or subtraction in the top or bottom, you have to add those fractions first. So like on this example here, I don't have to do step 1. It's not applicable because I'm not adding or subtracting fractions. So I can jump straight to step 2, where it says perform the division by multiplying the numerator by the reciprocal of the denominator. And so here I would get 5 times 1, or 1 times 5, which is 5, over 8 times 2, which is 16. And that would be my final answer. I can't reduce that anymore. That's it. Now, if you are dealing with, if you are dealing with one like example 2, where you are actually adding in the numerator or denominator, then for step 1, I'm going to come off to the side here and do some scratch work. If I have x over 2 plus 2, well, remember this is over 1. And so my least common denominator would be 2 times 1, which is 2. So I need to do a 2 there. So I end up with x over 2 plus 4 over 2, which would be x plus 4 all over 2. So I've now made the numerator a single fraction. Technically, it was 2 fractions added, right? X over 2 plus 2 over 1. But now I've got it as a single fraction. And I'm going to do the same thing for the denominator, x over 2 minus 2. Well, for the same reasons, my LCD is 2. So I end up with x over 2 minus 4 over 2, which is going to be x minus 4 all over 2. Then I'm going to do step 2, which says to copy the numerator. So x plus 4, x plus 4 all over 2 times the reciprocal of the denominator, which will be 2 over x minus 4. And so for step 3, I'm going to note that you can do this, right? You can cancel out those 2's, and so your final answer would just be x plus 4 over x minus 4. That would be it. And it drives me crazy, those x's. But that would be my final answer, x plus 4 divided by x minus 4. Now, if that technique really bothered you, there is the second technique. So I'm going to show you guys down here before we actually move on and look at the second way of doing it. This is the way that I do it if I have adding or subtracting, because I don't want to deal with adding or subtracting most of the time. So what I'm going to do, here is I'm going to look at my original problem. It was x over 2 plus 2 divided by x over 2 minus 2. The next method basically says to multiply the numerator and denominator by the least common denominator. So again, these are over 1. And if this is the only, like 2 is the only denominator I see, so therefore it is the least common denominator. It's the only denominator. So you're going to multiply everything in the numerator by 2 and everything in the denominator by 2. But what that really means is this. It really means that you're multiplying all of these terms by 2. Yeah, sorry, I was lazy. So I'm going to multiply this times 2, and this times 2, and this times 2, and this times 2. And so I would end up with 2x over 2, or simply x, right? Plus 4 over 1 divided by, again, you could cancel that, or you could think of that as 2x over 2 minus 4 over 1. But lo and behold, just like I said a second ago, this simplifies to x plus 4 in the numerator and x minus 4 in the denominator, because those divide off, and then 4 over 1 is 4. So that's actually a little bit easier of a technique. So, oh my gosh. So that's what this next one says. Find the LCD of all the fractions, and then multiply both the numerator and denominator by the LCD. So here, the LCD here is a little trickier, but if I think about my denominators here, let's think. I've got a 3 and a y, right? I've got a 3 and I've got a y. But I also have a y squared, don't I? So aren't I going to need another y here so that I have that y squared? And then I have a 6. Well, I've got a 3, so all I need to do to get a 6 is multiply by 2. So if I have 2 times 3 times y, well, that didn't really do good. 2 times 3 times y, notice this. I've got my 3, all right. I've got my y, all right. I've got my y squared, and I've got my 6. So all the numbers I have are there that I need. So what am I actually multiplying by here is 6y squared. So I'm going to take 1 over y squared and multiply it by 6y squared. Oh, that didn't mean to happen. I'm going to take 2 over 3 and multiply it by 6y squared. I'm going to do the same thing to the denominator with 1 over y minus 5 over 6. I'm going to multiply them all by 6y squared. Now, some of you are better at seeing the canceling than others, and that's fine. Remember, again, these are all over 1. So what's going to happen with this one is the y squareds are going to cancel, right? If you were to multiply those together, you would, or if you were just to cancel, those would cancel, and you get 1 times 6 over 1, which is 6. But if you don't like doing it that way, you can multiply 1 times 6y over y squared times 1. But like we said, that's going to give you, what's it going to give you? It's going to give you 6. Oh my gosh, sorry. Now for the 2/3. You can either recognize that 3 goes into 6 2 times. So you have 2 times 2 times y squared, which is 4y squared. Or if you didn't want to do that, you could have multiplied and gotten 12y squared over 3, which this again is still going to give you 4y squared. All right, same thing on this denominator here. You could recognize that you're going to end up with 6y because one of the y's cancels, or you could multiply, you'd get 6y squared over y, and that's going to leave you with 6y. Again, here, you can see that the 6's cancel and leave you with 5y squared, or if you multiply everything together here, you would have 5 times 6y squared, which is 30y squared, all over 6. But this is going to reduce to 5y squared. And there's no common anything, so I am done. So this would be my final answer. Now you could have, if you wanted to, there would be no reason for it, but you could have written the numerator like this, and you could have written the denominator like this, but there's no need to do that because nothing's going to cancel. All right, last one. I love these because there's only one denominator, right? I mean, this is over 1, but multiplying by 1 is not going to change anything. So since there's only one denominator, then that means my LCD, my least common denominator, is just y. So I'm going to have x plus 1 over y divided by x over y plus 2. And I'm going to multiply each of these by y. And so in the top, it's going to be like that. So in the numerator, the y's divide out, leaving me with x plus 1. In the denominator, right here, the y's are going to cancel, leaving me with x plus 2 times y, which is just 2y. And that's it. I'm done. Again, if you need to see it as x plus 1 over or times y over y, all over xy over y plus 2y over 1. Like if you need to see these over 1s, that's fine. But things are supposed to cancel. We want them to cancel. We want it to happen. And there's nothing I can factor here, so I am done. So simplifying complex fractions really is not that hard. If you look on homework 14, that's all these problems, number 8 through 20. Number 19 is a little challenging, but you should remember how to factor x squared minus y squared. But number 19 is a copy dot flip because you have a single fraction divided by a single fraction. Let's see. 14, copy dot flip, single fraction by single fraction. 8, 9, copy dot flip. So 8, 9, 19, and 14 are the best ones to use with copy dot flip with method 1. The rest of them, it's better to use the multiply all the pieces or all the terms on top and bottom by the least common denominator. But that is simplifying complex fractions 101.